Assalamu alaikum students. Welcome to our channel. Yes, we are here again with some new, more important questions, and the topic is integration. In the last video, we started the integration, and we are going to continue with questions in which we will learn how and where we use integration as a tool. In this question, they ask you to find the equation of the curve. The important thing is equation of the curve. If they ask you about the equation of the straight line, yes, we will use y is equal to mx plus c. But in this case, we will integrate the gradient, integrate the dy upon dx. This is how I can get the equation of the curve. Let's see, start with this equation. We have integrate the gradient so that we can have the equation of the curve. Rules are simple. We add 1 in the power and we divide by the same power. Here the power is 1, so we add 1 in the power and this is 1 plus 1. In this 10, we have x with power 0. But we will add 1 in the power and divide by the same power. And don't forget to add the constant c. So we simplify, it's going to be 3x cubed over 3 plus x square over 2 minus 10x plus 3, or it's going to be x cubed plus 1 over 2x square minus 10x plus c. But the important thing is, yes, find the value of the constant c. Now, how do I get the constant c? Very simple. Substitute the value of x and y in the equation that you just acquired here. So the value of y is minus 7 and x is 2. So I substitute 2 in place of x in the equation. 2 square minus 10 times 2 plus 3. So minus 7, this is 8, this is 2, and this is 20. So minus 7, and this is 10, this is minus 10. We move, this is plus 10, and the c will be 3 now. But we are looking for the equation, that's why we put back the c into the original equation, and the equation will be y is equals to x cubed plus 1 over 2x squared minus 10x plus 3. This is the required equation of the curve. This is how we use integration as a tool. Okay, let's move on to the next question. Sorry, I need to erase this line. Yes. Let's move on to the next question. And the next question is, yes, again, we have a derivative and they ask you to, the equation, yes. So for the equation, definitely, you are absolutely right. We integrate the equation. And we will get the equation of the curve. It's going to be 3 over 1 plus 2x to the power 2. But before integration, as you know, variable should be in numerator. That's why I bring up this bracket and the power sign changes, becomes negative. Now we integrate, the constant will 3 will remain same, the bracket will remain same. We will add 1 in the power. We divide by the same power. And don't forget to multiply by the coefficient of x, which is 2. Look at there, I multiply by 2. Don't forget. And finally, yes, the constant c. You must remember the constant c in the end. Let's simplify. It's going to be y is equals to 3 1 plus 2x whole power minus 1 divided by minus 2 plus c. Let's bring down this bracket. It's going to be negative 3, which is 2, and 1 plus 2x whole power plus 1. But the missing thing is c. So substitute the value of x and y and get the value of c. Y is half and x is 1. 1 over 2, this is minus 3, 2 times 3. This is 1 over 2, this is minus 1 over 2 plus c. So c is going to be half plus half, which makes c 1. Yes, but we are looking for the equation of the curve. So put the c back into the equation and it's going to be y is equals to minus 3 to 1 plus 2x plus 1. This is your required equation of the curve after integrating the gradient or dy upon dx. Okay, let's take another question, see how integration. Okay, again, we have to find the equation of the curve. Dy upon dx is given, point is given. Yes, let's go for the steps. To get the equation, we integrate the dy upon dx or the gradient. We will add in the power and we will divide by the same power. Minus 6, since the x is not here, therefore x will be power 0. We add 1 in the power, it's going to be 0 plus 1 and plus c. Very important thing, the constant c. Yes. It's going to be, this is 3x power 3 upon 2 and this is 3 upon 2 minus 6x plus c. Now here what happens, the 3 upon 2 becomes reciprocal, it's going to be 2 upon 3. This is 3x power 3 upon 2 minus 6x plus c. As you can see, the 2, 3 cancelled out. We have final form as y is equals to 2x power 3 upon 2 minus 6x plus c. But final thing, yes, you're right. Let's find the value of c. Substituting the value of x and y, the y is 2 and x is 9. This is 2, this is 2. 9 to the power 3 upon 2, we write 3 square instead of 9. This is 54. 2 is going to be cancelled out. 2 power 3, 27 times 2, which is 54 minus 54 plus c. Therefore, the c will be 2. But our last required thing, the equation. So it's going to be, so we substitute the value of x and 3 in this equation. So y is equals to 2x to the power 3 upon 2 minus 6x plus 2. This is the required equation of the curve. Okay, let's take on the next question. Question number 15. Yes, again we have the derivative. We have looking for the equation of the curve. Okay, means we again the integrate the gradient. So y is equals to 2x squared minus 3dx. The first thing first, we integrate 2, and this is 2 plus 1 divided by 2 plus 1. Here 3 with no x means x power 0. That is why we will add 1 in the power and do the same thing in the denominator. And finally, the constant c. So y is equals to 2 upon 3x power 3 minus 3x plus c. Okay. Now substitute the values of x and y. Y is minus 2 and the x is minus 3. 2 over 3 and this is minus 3 power 3. 3 times minus 3 plus 3. It's 2 over 3 and this is minus 27 and this is 9. So it's going 3 times minus 9 minus 18 plus 9 plus 3 minus 2 minus 9c. So c is going to be minus 2 plus 9 and c will be 7. But we are interested in the equation. Therefore, we put this value. So y is equal to 2 upon 3 x to the power 3 minus 3x plus 7. This is the required equation of the curve, right? Okay, let's move on to the next question. Let's see what happens in the next question. What they ask you the next question. Yes, we have a diagram and they ask you the area under the curve, which is bounded by x-axis. So very simple again, just integrate the equation. The important thing in this part is we have equation of the curve, not the gradient of the curve. So remember, whenever they ask for the area, they are looking for the area, you must integrate the equation of the curve. And the limits are also given. So it means to get the area, we are integrating this equation x cube minus 8x squared plus 16x. After the integration, we will apply the limits 0 and 4. As you can see, this is 4 and here it's a origin, therefore x will be 0 here as well. Now, in case when we have the limits, we integrate, same rules will be followed, but the last thing is there will be no constant c at all. Okay, let's integrate the equation. It's going to be 3 plus 1 divided by 3 plus 1 minus 8. 2 plus 1 divided by 2 plus 1 plus 16 x power 1 plus 1 divided by 1 plus 1, and I'll repeat, no constant c because the limits are given. Okay, let's simplify. It's going to be x4 over 4 minus 8x cubed over 3 plus 8x squared, and the limits are 0 and 4. So the 4 is called upper limit and 0 called the lower limit. So what we do, we substitute each value one by one in place of x. First thing first, I'm going to substitute 4 in place of x. Now I substitute the lower limit. Since I substitute the lower limit, so all the brackets become 0 and there is no need to show it again and again because every bracket becomes 0. So let's calculate. It's going to be 4 power 3. It's going to be 68 upon 3 and this is 64 and 8 times 16. This is what we have to simplify in this case. Okay, G, we have 64 minus 8 times 64 divided by 3. And then we have plus 8 times 16. The final area is going to be 64 over 3. This is the required area covered by or bounded by the curve and the x-axis. So whenever the curve is given bounded by x-axis, you integrate the equation of the curve to get the area, right? Remember this. Okay, let's take the next question. I tell you, integration is not going to be changed. Yes, we're just using the application. Now we're looking for the integration, how and where it helps you. Okay, so let's integrate the second part again. In this, we integrate the curve by limit 1 and 3, and we have 2x and 3x power minus 2. As you know, we must have variables in the numerator. That's why it's being it numerator. All the integrations are same. So 2x square over 2 plus 3x power minus 1 over minus 1. And this is x power 0 plus 1 divided by 0 plus 1. I repeat, no constant c. It's going to be x squared minus 3 upon x minus x, and the limits are 1 and 3. The first thing first, we substitute the upper limit. It's 3 squared minus 3 upon 3 minus, that's the upper limit, and then we write the lower limit. 1 square minus 3 upon 1 minus 1. 9 minus 1 minus 3, that's my first bracket. And the second bracket says 1 minus 3 minus 1. Your area is going to be 9 minus 4, it's 5. 1 cancelled out, it's going to be plus 3. So the area of the bounded by the curve and the x-axis is 8 units. Okay, let's try the next question. Now, in this question, there is a slight problem that the area should be under the curve, but right now it is above the curve. So what we do, we reflect this curve in this way, and we will get the area of the shape. But the question is, how can I reflect? It's very simple. What you do, whatever the equation you have, you multiply the equation by minus sign and then integrate the upon the limits. And the limits are 0 and 5. This will give you the area of the shaded region, which is equal to the required region. So let's open the bracket with minus sign. It's going to be minus x square plus 5x dx. And the limits are 0 and 5. So area is equals to minus x cube upon 3 plus 5x square upon 2. And the limits are 0 and 5. First thing first, we substitute the upper limit minus 5 power 3 over 3 plus 5. This is 5 square over 2 minus the lower limit. So 0 cube over 3 plus 5 over 2, 0 square. Fortunately or unfortunately, the right bracket becomes completely 0. On the left side, it's going to be minus 125 over 3, and it's 125 over 2. And the last bracket becomes a 0. So let's subtract them. Minus 125 divided by 3 plus 125 divided by 2. It gives you, yes, the area is 125 over 6. Just once, let's end our class here, inshallah ta'ala. In the next video, we will discuss some more questions about the differentiation and integration and other topics. Thank you very much. Very much. Take care. Till then, Allah Hafiz.